Hello, good afternoon. We're very glad to have this conference today. We have with us Benjamin Ball. Benjamin is the first time that he's coming to IAAC, and thank you for being here today with us. He's an important person that we always use as a reference in many of the projects related with digital fabrication, so we're glad that he's here today with us to share his vision and share the process of his work. I would like to maybe read a bit of him, for the people that they don't know. So Benjamin Ball, he is an architect from Colorado. While studying at the Southern California Institute of Architecture, Ball logged stints at Gehry Partners and Shirdel, Zago, Kipnis. Upon graduation, he sought work as a set and production designer for films, including the Matrix series, that you should explain about it, as well as music videos and commercials with such influential directors as Mark Romanek and Tony Scott. His experience ranges from work on the Disney Concert Hall and small residential commissions for boutique firms to complex medical structure and event design. He's currently the principal of Ball-Nogues Studio, that is, has exhibited at major institutions such as the Museum of Contemporary Art in LA, Los Angeles, the Museum of Modern Art, the Guggenheim Museum, PS1, LA Country Museum of Art, the Venice Biennale, the Hong Kong, and etc., etc., etc. The studio is currently working on permanent and public commissions for Los Angeles World Airports, the city of West Hollywood, the country of San Diego, Houston's Buffalo Bayou, and Nashville Music City Center. So there is a lot of project going on, and we're very much interested to listen about it. Thank you for being here with us. I hope you enjoy this night. I already explained to you, but we are like a very nice group of more than 100 people coming from 35 different countries. And we're very glad to have you here with us. Thank you.
Thank you. Okay. Well, it's good to be here. It's odd sitting. I always thought that I saw Peter Eisenman give a lecture, and he said that that Colin Rowe told him that when you get to be 80, you can sit when you give a talk. And I'm only 44, but I have a lot of jet lag, so I've been traveling a lot. But I'm very, very happy to be here, and I was very excited when Areti invited us, and she invited us to do a workshop, which we couldn't do presently, but I hope we will do in the future, because it doesn't take much effort to get me to Barcelona. Because I love it, and Gaston as well, although the two of us at the same time is very difficult. But as I said, I'm very happy to be here. I love being here. The talk that I'm giving, I guess I'm going to call Designing Production. And I think that it is something that will be somewhat familiar to people in this institution. I hope that there are some things that you're not familiar with, but I think that the way, the reason I call this Designing Production is because I think that we have a kind of alternative model of practice. I would loosely call ourselves architects. We don't always define ourselves as architects. That has its drawbacks and its advantages. But we seek opportunities that are outside of architectural kind of milieu, and also out of what I would call the kind of conventional kind of academic approach to working in an experimental manner. We try to create the laboratory within our own studio. So imagine this school is kind of like our studio, I think. There's a lot of very similar, strong similarities. And tonight I'm going to show you several projects where we've fabricated everything that we designed, and we've designed everything that we fabricate. And I begin this with this picture of the dome in Florence, Brunelleschi's dome, because I think that this notion of designing production is something that has been lost on the architectural profession somewhat, at least with respect to a lot of the kind of dogma of the popular dogma of modernism and postmodernism. This kind of notion that the architect is the maker, the architecture is the builder, the architecture is the designer of the tools of making, is something that is really becoming once again very important, as it was when Brunelleschi designed not only the dome but the apparatus to make the dome. And it's important to think about the fact that when he was buried, he was the first kind of non-pope person to be, or clergy person to be buried, or non-rich person to be buried in the church. But then also they identified him not as an architect or as an artist, but a maker of fantastic machines. And so I think that that's something of what we do. I always show this slide in my talks. I used to call this talk Spaces Between the Hammer and the Mouse, but this image kind of represents our kind of frustration with the kind of digitalization of architecture, the over-digitalization of it and the use of it for representational purposes, and also represents the kind of tension between the physical and the digital. We're really interested in that space that's right there. Can I get there? Usually I have a pointer. We're interested in that. I'm not even going to try. The space between the hammer and the mouse. So it's a kind of a craftsman's mentality and a craftsman's way of doing things. These are two images that represent kind of one aspect of my former self and an aspect of my partner Gaston Nogues, his former self. Gaston worked for Frank Gehry for about 11 years, and I worked for about 6 or 7 years in the film industry as a set and production designer. And these two images represent, I think on the left, the World Cup of Hockey trophy that Gaston worked on with Frank, that is a kind of, comes out of a kind of craftsman approach to design, where the limitations of the material, the production methods of the material are determining the range of form. And then on the right is a set that I designed for an Audi commercial, I believe, in the mid-90s, which is a very different approach to making, where it's a kind of an image maker. So, but it's not to say that I don't do what he does and he doesn't do what I do, but it's this combination of histories which has enabled us to create Ball-Nogues and the feedback loop between these two different sensibilities. The kind of craftsperson versus and the image maker, material performance and storytelling. This is our studio. It looks very much like what you have here. I should say this is all fabrication space, and then we have a little office. Actually, it's exactly the same layout as you have. The office space is upstairs where where it's clean, and we're always constantly dealing with dust. So another thing that in our past is hot rodding, something that I don't know if it's that common in Barcelona, maybe, but this is a car that Gaston built while he was working at Gehry's. And if you know anything about how this works, at least in Southern California, this car is not a particular car. It is about 10 different cars. So if you know the Johnny Cash song, One Piece at a Time, where he's talking about what his car is, it's like a 57, 59, 50, 58, 62, all these different cars cobbled together. So this is about really using the least means to achieve the most. And I think that that's something that's very possible in at least hot rodding in the California climate, because you can actually work outside. You can do it yourself. You don't see people doing this in Toronto as much. You don't see it in New York. So its climate contributes to the way that we operate. And it's the development of this through doing this over and over again, development of know-how and how to do more, how to extend what we've done before. This is an image of a Ford factory. I talked about production design a moment ago. This is Henry Ford's factory, where he's really designing the factory prior to designing the car itself. What enabled him to design the Model T and the Model A was designing the factory and the method of production first, before he could contemplate the form of the car. That is very similar to, in some respects, to the way we work. I would describe our work as a very tight integration of concept, computation, and fabrication, and working in this manner incrementally. So each project is an incremental development of the last. A project is not defined by the venue that it's displayed in, but rather the method of inquiry, and that may mean that we drop an installation in New York, in Barcelona, in Paris, but they're all based on the same inquiry. And I think that, working in this manner really gives one, as a young designer, power. That is something that I think is rarely discussed, is how is power attained within architecture and design. Well, if you hold the keys and the knowledge to particular methods, and you own a fair amount of the equipment that can facilitate those methods, then you have a tremendous amount of power compared to somebody who doesn't have that knowledge. Somebody can buy it, but they're probably going to buy it from you. So our work began in 2005 with this project. I'm going to walk you through a couple of quickly a couple of old projects, and then show you some things we did in the last couple of years. This was a project called Maximilian Schell. This was made for about $5,000. Oh, okay, great. Over the course of took about a year to design, and about 2 weeks to fabricate, and about 3 hours to erect. It may not be particularly, from a computational standpoint, interesting at this point, because I think most of this stuff is kind of well known about how to do this. But it did define a kind of working method for Ball-Nogues, where we really interrogated a material, and we interrogated a method of working with that material. I won't get into kind of the particulars of it from an experiential standpoint and so forth. Because of that project, we were then invited to participate in the PS1 annual competition for the Museum of Modern Art in New York, and we won this competition. And what we decided to do, and the reason why we won, I could say, probably with a fair amount of confidence here, is that we proposed advancing a process that we had already developed and that we already understood, and therefore we could prove its feasibility. And so we essentially took this Maximilian Schell project, some of the key kind of constructional aspects of it, and kind of put them on steroids and develop them for a more demanding environment in terms of wind, in terms of longevity, in terms of rowdy, drunk, stoned crowds that would ransack it during the weekly musical events that happen there. And then, you know, as a metaphor, of course, it has interesting implications. It's a circus tent in a prison yard. It's also a kind of low culture object within a kind of high culture environment. But to us, what we were really exploring was this kind of tessellation concept, tiling concept over a minimal surface. There had been very little done with this in 2005, so I felt at the time it was something of an innovation. But this project also mixed the handmade, in that we worked with an artist from New York, Sheila Pepe, to produce these kind of seating nets that were underneath this canopy that were essentially the same form and the same structural principle as this kind of high-tech canopy over one's head. Utility poles holding it up, common. So I'm going to talk about several projects that the project is actually this, not the name of the project in the venue. We did a project called Rip Curl Canyon, but it's an example of a process that we developed, and these are processes that I call that have these kind of 5-minute academic titles. I call them 5-minute academic titles because they're always in a constant state of evolution, and I think to define them too clearly would mean that they would become kind of fixed, and we don't want that. These ideas are continually transforming. So I'm going to talk about each of these. They span over several iterations, if you will. So the first we'll call continuous micro offset printing, or stacking, and this grew out of a project that we were invited to do by Frank Gehry in 2006 to commemorate the launch of his jewelry line. I'm not going to talk about this project very much, other than just to get you up to speed on how we did it. We were challenged with making something which kind of honored Gehry, but at the same time extended the notion of luxury for the Tiffany brand. So what we proposed doing was taking this idea that Gehry had used with his furniture in the 70s, these die-cut cardboard pieces, but instead of extruding the die-cutting, the stacking, we were going to shift it as though like a deck of cards to produce a kind of a more undulating and a more robust formal vocabulary. If you're not familiar with die cutting, it's essentially like cutting cookies, when you kind of push the cookie and make an impression. So this is a rotary die, and these are the plans for the designs for the die. So we're working with these strips and looking at kind of maximizing the amount of space that we can get out of the die. So this thing chucks out about 6,000 impressions an hour. So you can create this in an hour. And then have it delivered and separate it, and then we began to experiment with ways in which we could shift the pieces relative to each other. So we had done this at the Tiffany project, which was essentially a wall, a display, and so when we were invited by Rice Gallery in Houston to do a project there, we looked at how we might make it actually an inhabitable landscape which one could walk on, which one could climb upon, and that would live, rather than for the 2 hours that the Tiffany project was meant to last, this would last for 7, or I think maybe 3 months. Again, I'm not going to talk as much about the experiential aspects of this, the kind of metaphorical aspects of it, because I want to talk about the production. But what we were asking ourselves is, can we expand this production technique to be more architectural? And then can we also extend the casual social space of the gallery, or the campus, into this gallery, so that it would become not so much a rarefied art object, but actually an inhabitable, usable part of the campus. And again, we're working with this stacking idea. We're building a parametric model of it, which essentially accounts for the shape of the material, and it really just allows us to twist and turn the stack of cardboard as though it was physically in front of us. We oftentimes start out with a diagram. So it's really the diagram combined with the production proposal or concept that remains consistent. As long as you have the diagram, essentially starting in the back of the space. This is a vestibule, so you walk in and you see through the glass, and there's walls here. So you see these big, we called them ribbons. You see these kind of ribbons that have a kind of plateau on the back, and then they kind of break apart like crashing water in the front. But this is essentially the diagram. It's not the final form, but this really defined the kind of topology, if you will, of the project, and that enables us then to make a parametric model. We're not really interested in the kind of theatrics of representation that you see coming out of Los Angeles sometimes. So this is an image of it from the front. You see the vestibule creates a kind of space for exploration, kind of land exploding into the water, and it's this kind of a sense of can I come in here and climb out and look around? The modeling again, a kind of comes out of thinking that I was actually doing with Marta Male. In SciArc, when we were working with Top Solid, kind of expanding on that, this idea of mechanical engineering software becoming creating kind of working, malleable prototypes for architectural assemblies. So this is essentially the same thing as this, a kind of mechanism, a kind of machine. One of the first steps involved in this is exploring how far can we push the material in terms of undulation, in terms of formal variation. So here we're studying the twist of it, and here we're studying rippling. The idea is that if you put too much rippling, you put too much twist in it, that if you stand on it, your foot will go through it. Obviously, if you have two pieces of cardboard that are attached like this versus like this one is much stronger. So the question is how much offset can you actually achieve without while maintaining structural integrity. It is not actually made out of wood, but this is a kind of more of an armature to hold up the cardboard. The cardboard is really, I would describe it as a kind of semi-monocoque, and it's raised up into the air into this to give it this kind of configuration, a kind of a topography. Only maybe 15 days to assemble. The only measuring involved in this was actually making a plan, laying out the locations of all the points where it meets the ground. At about this time, we decided that this was a very fruitful, this is in 2006, a good way of working, and that we started to recognize that architecture had a kind of contempt for labor, as did art, that labor has become devalued and debased, and we couldn't really understand why, and we decided that each of our projects perhaps might attempt to challenge that tendency. That's me. And the irony is that now as our projects get bigger, it becomes a lot more difficult to actually do that. So, but I still think that we do prototype, and we do create mock-ups, and then if we need to sub out pieces of it, we do that. It was a kind of space of adventure, kind of playground. The underside had a very different feeling. People had kind of classes here and hung out. Drinks, drink rails, benches. Okay, so moving on to another set of projects. These I call suspensions, or you could call them gaseous pochés. We were interested in working with a variable unit again, as we did with the Maximilian Schell project. And the physical manifestation of the unit in this case was a catenary. We all know what a catenary is, I assume. And we wanted to explore the full potential of this. We were invited by Extension Gallery in Chicago to do an installation. This is the installation that we did. Now I'm going to talk to you about how we did it and why we did it. That is the space. We were offered a $2,000 budget, and that's barely enough for us to fly there and eat. So we thought, well, we need to make something that is extraordinarily lightweight and can be packed into a suitcase. So it came at a kind of this was, I don't have aha moments, but this was an aha moment when we decided how to do this project. We had been looking a lot at Freado, and I had recently been to New York, and if you've been to New York and been to the Four Seasons restaurant, designed by Philip Johnson in Mises Seagram's building, you have to go. You'll pay $30 for a drink, but you have to go. It's worth it. You might see like Michael Bloomberg in there or somebody. But this, the Four Seasons has these beautiful curtains, which are made of chains, and each of the chains is an individual kind of catenary. And then we'd been looking at Otto, and I thought, what if we take this, rather than this being, these are actually kind of analog models for producing thin shell concrete structures, optimizing thin shell concrete structures. And I thought, well, we're not going to be doing that here, so why don't we take this idea as a kind of diagram and expand it into three-dimensional space and use it to kind of delineate a space. Let's throw ideas about solidity and architecture away and think about architecture as a kind of delineation of space. If you've ever looked at the work of an American artist named Sandbeck, this was an idea that he proposed, but he did it in a much more kind of abstract manner. So let's take these hanging variable catenaries and expand them into 3 dimensions. And our first, and kind of shape a space with those catenaries. So our first attempt at this was done in an analog method, making this kind of plywood model, and we knew that it was going to become very challenging to do it that way, because we wouldn't be able to make iterations quickly enough. So we started working with a software developer to create a plugin, actually for Form Z, that enabled us to parametrically modify and manipulate the length of the catenary, or the depth of the catenary, which we call and the distribution of the catenaries along a wall. That's what is happening here, and the low point of the catenary, and the shape of the distribution, etc. And we found that we were able to actually design now, rather than be burdened with the tool, previous tool being, of course, the analog model. Now, what we developed with the software was the capacity to design, but then also to create output for for fabrication. In fabrication, remember again that this has to be a very small, lightweight project that can be transported easily. Fabrication is simply cutting a length of string and then labeling that string and then attaching it to a place on the walls. So we developed this kind of machine made of people to cut the string to length based on numerical output with about 8 people working in unison. And then we cataloged all the pieces. I should have put this slide earlier, but the basic principle behind this project is this. This is a very American thing. But now some people in America would call this craft. I don't call it craft. I could do a whole other talk about what I see the meaning of craft as being. This is what we call in America, at least people who take craft seriously, this is what's called handicraft. And this is something that you can purchase in a store, and then this is a latch hook rug, but this is the idea behind the location and the mapping of the points and the launch points of the catenaries. As long as we could create this kind of map, which was made with a billboard printing machine, about a 3-meter wide machine which prints billboards that you see polluting our cities, printing onto mesh the precise location of all of the catenaries, hanging them up, unfurling them, and then voila, you have a kind of 3-dimensional aerosol painting, and then kind of dithering the color from one side to the other. There's nothing arbitrary in this whatsoever. It's completely controlled. And it becomes a kind of brush stroke in space, and then also this kind of delineation, this kind of poché that's very permeable. We couldn't decide what it was physically. It's not solid, it's not void, it's not a sponge. What is it? It's a suspension. Suspension like blood or like milk, solid particles floating within a medium of liquid. About this time, my partner, as I said, he's, again, like in Southern California speak, we would refer to him as a gearhead, which is someone who is very, very good mechanically. He said, I don't think that we need to cut these by hand anymore. I think we could produce a machine that would enable us to cut the string as well as paint individual discrete locations on the string. And about that time we'd been invited to the Venice Biennale, and I said, well, okay, well that will become our deadline, is the Biennale, let's try to get this machine done. So we went about doing it. This is actually the final version. There were several iterations of this prior to arriving at this. I do the drawing to prove that we did it, that we didn't buy it somewhere or have somebody else do it for us. And this is a kind of patent drawing. So if you take a picture of this, hopefully you won't copy it. But there it is operating. It is, as you all probably know who work with machines, often machines that of your own design that you have hacked are not friendly machines. And that's a good thing, because if it was friendly, then everybody would be doing it. And that's a kind of our philosophy. I'm going to show you a little... let's see, come on. It's some images of it operating. So it requires sort of constant maintenance. You're trying to cut, a typical project would require, this project we did at the Museum of Contemporary Art in Los Angeles had 3,700 strings, I think. Each of them unique. So you have someone operating the machine. The machine has a stepper motor, which is manipulating a drive wheel, a free wheel here, which is pinching it. These are off-the-shelf standard airbrushes, which have been placed into a chassis which is triggered by solenoids. All of this, of course, linked to the software. And then the string carries through the series of brushes, and you can see the brushes can paint in very discrete locations. And we're working with cyan, magenta, yellow, and black, which are standard printer inks, which has a rhetorical purpose on the one hand, because we wanted to make a point about this being related in some regards to printing, but then we also we like those colors, and it's also a very practical consideration, because those colors, we can also mix colors, so that means that we have 16 variants that we can create based on combinations of 2 of those colors. So you get the idea. I won't bore you anymore with that. But the result is something akin to a Central Asian textile process called Ecot. If you don't know about Ecot, you should look it up. It's very interesting. Ecot involves placing yarns into as the weft into a loom. Marking out a pattern on the yarns, removing the yarns, and then individually dyeing the yarns in discrete locations, putting them back into the loom, and then applying the warp. And that kind of a process is so so labor intensive that it doesn't really happen except within, it requires a kind of entire community to do it. You have some people weaving, you have other people laying, putting the resistance over the string so it doesn't absorb dye, and you have other people that are dyeing blue, another family is dyeing red, etc., etc., etc. So consequently, these things became extremely valuable in Central Asian, Southeast Asian cultures. So it looks, it's a little bit like 8-bit graphics, I think. So you can see it's kind of jerky and crude. But that's really what these projects are, in a sense, is a kind of 3-dimensional Ecot. So we were invited by the Museum of Contemporary Art to do a project that was about the convergence of computation and craft. We called this Feathered Edge. And you can see this is a building designed by Cesar Pelli. It's a kind of skylight, and we attached the strings up into the this skylight, almost as this kind of atmosphere which is pouring out of the skylight. And our first interest in the machine was to make representational objects with it within this array of catenaries, to make things that our eye would recognize. And so this was our first kind of attempt at it, and we used these kind of spheres, which we quickly decided was quite boring, and we switched to an algorithmic approach, where I won't get into the details of how it was done, but when we went back to create a solid based on that algorithmic approach, it looked something like this. So you have to imagine this being intersected in this array of strings to create these kind of this condition of color that is suggestive of solid but not quite solid itself. There's the ceiling, the pattern that the strings was hanging from. And the result. This was kind of exceeded our expectations. I was very happy with it. But it's interesting to us because a lot of the aesthetic qualities, the formal qualities, the experiential qualities of it, we couldn't define until we had done it, which contradicted a lot of our training, where we were always told that you have to have this agenda and this clear notion of what it is that you're trying to create for the user or for the viewer. In this case, we're really working in a very in a way where we don't quite know what this is going to yield in terms of effect until it's finished, and thereafter we began to theorize it. But you can see one of the main characteristics of this is as one moves through it, the color blends. So the magenta will blend with the cyan to yield a purple. So it's blending optically in the way that a Ben-Day dot does in printing. Another aspect of it that became very interesting to us is that can't see it yet, but as you move around it, sometimes the color has a very clear geometric quality to it. It has very graphical kind of gestures, and then at other times it's very nebulous. So it's the tension between these two states that really creates the intrigue and invites the viewer to move around the piece. We were also thinking, we should try this idea of a representational approach to the application of color. So again, we were invited to a biennale in France, and in this case, these are hanging. The catenaries are hanging from these arches, and we imposed a kind of solid block wall, which you can see here. The model of it, so this idea of this kind of immaterial wall, we called this Spock's blocks. I won't explain why, it's too much time. Taking the idea to another venue, and this time thinking about it as a surface. The catenary couldn't be a unit for creating surface. This is a very kind of open and large entryway to a museum in Indianapolis. So rather than kind of creating this volume of catenaries, we created a kind of a surface which twisted and rotated as it came down through the space, attached along the perimeter. We saw this as the building as akin to a kind of in a lineage of a Baroque, the Baroque dome, the oval-shaped dome, a kind of bad version of that, and so we thought that we would kind of make reference to that, and so we abstracted this dome and the cornice line from this dome, this Bavarian Baroque church called the Steinhausen Church, abstracted it into our CMYK colors, which eventually kind of looked like a brain scan, which was okay by me. And then here we see it. And then this project will then go further at the Bradley West Terminal at Los Angeles International Airport. It's a project called Sky Garden. In this case, we're kind of working with mapping the light through the array of catenaries from this deep light well as to create a kind of garden within the international network of airports, which I consider to be a little bit like being in a kind of endless shopping mall which blankets the globe. So the notion of a garden, something that kind of relieves the mind, relieves the senses for if only a moment, after somebody gets off of a 10-hour flight from Barcelona and has been probed and searched and gone through security, and I'm actually not going to show that picture since keep moving. I always show this slide. That is Frank Zappa, the band The Mothers of Invention in the 60s and 70s. It's important, I think, because he, at the time, was working in the musical avant-garde, but he wasn't, there was a lot of artists who were doing music, but were also exploring the score of music, and got to the point that they were taking the scores and putting them on the wall. as kind of art, and then the music didn't matter. And Zappa responded to that tendency by saying, you don't eat the recipe. If music is a kind of food, it's meant to be consumed by the ear, not by the mind. I kind of adhere to that belief myself, although I'm kind of showing you these images of process and production. I still think what's important is the experience of the work. We don't like to display works that are kind of just a kind of an outcome of a fabrication experiment. So about this time, we were continually being asked to do these installations, and we started thinking about how can an installation be dealt with as how can we deal with it with respect to sustainability? It has its own unique set of characteristics with regard to sustainability. Lead ideas don't apply. So we thought the best way to design an installation was not to just design the installation, but to design the disappearance of the installation. And so we first began that with this project in Shenzhen, which was at the Biennale, where we imported 17,000 T-shirts from American Apparel, which was a kind of an irony there, because American Apparel is all made in Los Angeles, but 98% of the clothing in the world now is made in Shenzhen. So something like that, I don't know. But and made this kind of hideous dragon thing, but could then be pulled. The clothing could then be taken away at the end of the installation. So the installation just kind of becomes part of the flow of materials through the culture. And then we took that idea further here in the project called Tablecloth, where we called this process cross-manufacturing, so that the component, in this case the parametric component, again, like we're not so into the kind of parametric tiling thing anymore, but at the time we thought the component could itself actually be a unique consumer product that could be taken home after the installation is over. So the challenge to us as designers was to design something that was both a building component as well as a useful and desirable object that would have a life of its own after the installation was up. This was at UCLA, where I often teach, and we did this project in collaboration with the music school. This is the courtyard that we were given by Hitoshi Abe, who's the director of the UCLA Graduate School of Architecture, and Tim Rice, who's the director of the music school. And kind of a horrible courtyard, the worst example of American campus planning in the mid-'60s. And so how do we make something that kind of brings this to life, but also serves as a performance space for music? So our approach is to make this kind of tapestry which hangs off of the rigid structure of the building, and then creates the different opportunities for performance within the middle, or in the round, different types of performance. But each of the components, each of the components, I should say, is a table that can be taken home after the installation is over. So you have a kind of relaxed drape using kind of form-finding techniques in collaboration with Burrow Happold. Then points are placed on the surface here. They're not there. Huh. And then we create a Delaunay triangulation using the points. And then we create a system of ovals that are attached in discrete spots to create a kind of fabric that hangs from the building. If you've seen the Paco Rabanne dress, it was lingering somewhere in our subconscious, I think. So the manufacturing involves making 267, I believe, unique tables that fit together in one way. Each table is unique, except there were these were kind of wasteful, but there's this one extra little piece with a kind of pivoting, or a kind of ball joint that connects them. A little bit like chainmail, maybe, in places. Each table was labeled as, like, we used the original Herman Miller template to design a label for each. And then one thing I didn't mention is that this is a very live space acoustically, kind of like the one that we're in right now. So the whole piece becomes also not a backdrop, but also an acoustical dampening device, as well as a seating area. And then the colors sort of match the late modern design. Now that's what you do when it's over. You take it home and you put it in your Rudolf Schindler house, assuming you have a Rudolf Schindler house. So let's see. So I don't think I'm going to talk about this because I'm running out of time. But another project. This is something we call limber structures. This is something I did with our students at SciArc. We'd done a project with the Coachella Festival, if you know what that is, in Los Angeles. It's a big music pop festival. And we proposed the idea of doing a studio that was built around the Coachella Festival to SciArc. SciArc was a little resistant at first, thinking, like, what is this, like, they don't understand pop culture. And it's like, well, it's just another opportunity to build. And that's, again, I should tell you guys, you should take every opportunity that you can get. So we proposed it as a studio, and the studio looked at, that's the final project. The studio looked at the history of the music festival from Woodstock to the festival of the Bacchanal to some of the environmental problems that are at festivals. That's the Pink Pop Festival in Holland. You can see all the trash. Coachella is a much cleaner festival than that. That's Coachella. And we began with 7 groups of students, and we asked them each to explore they weren't given a program, they were only given a budget and a set of logistical constraints. So it turns the idea of the traditional architecture studio on its head, where you're given a program, you're given square footages. We said that none of that matters. We're not even going to give you a use. All you have to do is propose making a structure, and you have to be able to do it on time and on budget. So 2 of the most promising explorations was one using flexible tubing, and another that we called the Big Honeycomb, which used polycarbonate tubes that were assembled into a honeycomb. And the end result ended up being a combination of these 2 ideas. One guy, Ben Lloyd Goldstein, in the studio developed this thing that we called the gem, which was a kind of unit that was based on the bending radius of the tubing. And so he was able to make this unit, and then we aggregated them to create a giant flexible ribbon that could then be bent and twisted and manipulated to create any different kinds of configurations that would be maybe appropriate for the venue. Involved camping for 8 days out in the desert. I find that that's a great way to work with students, is that you imprison them for 8 days. There's no opportunity to go drinking with their friends. There's no opportunity for them to see their loved ones. They have to stay there with us. But I shouldn't say this took 8 days to produce. We produced these first at SciArc, 275 of them, and then transported them out to the site, and then assembled them as 3-dimensional units, lighting, etc., and then twisted the whole piece into shape using cranes. The only way to do this, only possible way to do this, is via full-scale mock-up. Our engineer told us that we could span 35 feet using, that's 10 meters, using this system, which completely was erroneous. You could span about 2 meters with it, 1.5 meters. So the system is really way too complex to predict using a finite element analysis. And, you know, in the end, our engineer did just tell us, you know, the best way to do this is to build a mock-up. And I said, well, I could have told you that. So we did it, and luckily it worked. But it was about really developing an intuition for the material. There is no way to analyze your way into an answer for this. It requires what I would call tacit knowledge to discuss craft again, a kind of very hands-on knowledge and understanding of the material and what it feels like and how it feels to bend it. And I can tell you that each student that worked on this project understood how much you could bend that material and when it would break by the end. This guy showed up in a green screen suit, took pictures. All right, one more set of projects and then I'm going to stop because I'm running out of time. I think I have like 5 to 10 more minutes. These I call sphere packing, but then we also brought some of this idea of cross-manufacturing from the previous the tablecloth project into this. This is a public artwork. I could talk about public art. I'm not going to. I'm going to talk about the production of this particular project. The fact that it's public art shouldn't matter in the context of a discussion about production. We were chosen by the Department of Cultural Affairs to address this is a blank wall in the city of Santa Monica. If you've been to Santa Monica, it's very touristy. It's got this pier, pleasure pier, and our thing is at the end of that pier on the side of a garage. This was originally designed by Frank Gehry. We had a very limited budget for this. So the question we asked when we began was, could we take this concept of, this is what's called a Newton's cradle, and if you watched Hollywood movies, the bad guy always has this on the end of his table. So we thought this would be a very fruitful structural concept, as well as an interesting metaphor. So you know, you essentially take up your vertical loads with tension in a tensile structure, as a cable, and then your lateral loads are resolved into the wall via compression. Here's an image of it. Our first explorations, because this was a proposal, we weren't able to test the concept before we were to propose it, which is very different than the way we typically work. So you can see that this is a little bit of a fantasy. You've got these kind of gaps in there, but it did win us the competition, so that was good. We didn't propose a particular shape, we proposed a language of shapes based on the diagram of hanging, as I talked about earlier. But you could begin to see a lot of associations that one could have with this kind of form, with imagery which is germane to Santa Monica, the ocean, maybe people drinking on the beach. That's a bacterial culture. These don't have anything to do with Santa Monica, so I don't know why I'm showing you, but that's the eye of a fly. And so the question was, what is the unit that we're going to use? We know that we can do this with spheres, but we didn't know what kind of sphere we could use. We thought plastic. Then I said, you know, I have a friend who has one of these in his garden, or her garden. And if you know anything about these are called gazing globes in America, and they were meant in the Victorian era to attract gnomes. Do you know what a gnome is? Okay. But it's not part of Spanish culture. I don't even know whose culture it comes from. I think it's English. Are there gnomes here? A gnome is a little man that's like this, wears a big pointy hat. So the Victorians believed that if you put this in your garden, the gnomes would come. And I don't know, I don't know. And there's still some people that believe this. But So these are sold in garden stores. So we went to a garden store, we bought one, and we learned that some of them are glass and some of them are stainless steel. But there's, as we know, there's multiple grades of stainless steel. So we thought, well, if somebody's able to make these for $38, $40 a unit and sell them in a garden store, they certainly can make them out of a higher grade of stainless steel and make them for a comparable price. So we went direct. We after a lot of navigating through middlemen and resellers, we found we went direct. We found the manufacturer in China directly, and he showed us how he does these. It's quite interesting. It's a kind of flat primitive, which is welded very. In the case of China, it's done by hand, but here you could do it with your robot. And then inflated to several thousand kilos per square centimeter, I guess you'd say, and then polished by hand. But that is a completely unfeasible process to use in the United States or Europe. In China, this cost us something like $40,000. In the United States, the cheapest, the lowest quote was $270,000. Shipping included. So what you're making is essentially a kind of slip mold, and then you're pouring the spheres into the mold. The only thing you can predict is the mold. You can't predict the location of the spheres within the mold. That means this, X. This, yes. Those are ball bearings poured into a numerically CNC fabricated block of foam. So we're looking at the distribution of the spheres. This is a kind of digitally guided analog computer, I guess. And the overall scheme for this is that you make this kind of form. You attach the cables up to a tower. The formwork becomes a transportation jig. You put the transportation jig onto a truck. You prep your site by making attachment points along the site. You bring the truck to the site. You put this up on the wall. You attach these with a couple of forklifts, and voila, there you have it. So the real design of this is this, the formwork. How do you make something so elaborate on a very limited budget? You go back to my days in film, and we have something called rock and roll truss that's used for rock concerts, and you see it everywhere. You see it here everywhere. We know that this is pre-engineered, so we build a big, we know what it's capable of doing. We build a kind of armature that sits on it and uses it as the primary structure. It could be a giant skateboard ramp. We lightly weld the balls, spheres, create a facsimile of the anchorage point or the hanging point off-site, and then we transport it as a unit. So this is a very tightly integrated production and fabrication and delivery system. They all are working synergistically. And you drive it to the site. And this is what it's hanging from. It's a thick, very heavy piece of stainless steel. Have to put one of these pictures with a robot manipulating something, or else, I don't know. You always have to show that nowadays, right? Don't show it, you guys. We're going to like boycott these things. I had to show it once, though. Just to prove that you know how to use the robot. We didn't. We subbed that out. We didn't do that. Maybe I'll bring it to you guys next time. So this is about understanding what the fidelity or the resolution of the surface could be. It can't be a smooth surface. Like the Maximilian Schell project, you allow the materials in the Maximilian Schell project was a fabric. You let the fabric fall and drape and create its own kind of characteristics. And here you let it kind of do what it wants to do, and it creates this kind of little kind of moment within the city. I was talking about the shape being related to sea creatures. It was really, was this what we were after? I think that in public art it's very important to be subversive. That's why most architects are not good at it. They tend not to kind of speak that language. So I'm going to quickly go through one more project, then we got to stop, because taking this idea further to a compressive structure, another public artwork for Edmonton, Alberta. We were originally asked to make it integrate with this wall, and so we thought about making this kind of pile, this kind of dome pile of spheres that would be a compressive structure that would relate to the kinds of formations that you see along the river that is nearby, and sort of kind of taking this idea of the river and making the kind of freeway, that's this, where all the cars are, into its own kind of river. Well, we were eventually, the city sued the contractor who built this wall, and so we weren't able to do it here. So we had to think of a different metaphor, so we thought about it as a more articulate pile, as a kind of earthwork, if you will. This is the location. If you guys don't live in North America, so you don't have spaces like this except in central Barcelona. But this is like these kind of leftover spaces in the freeway cloverleaf. Probably the worst place possible that some people could imagine art. So our idea was to really go with that and make something that seemed like it belonged there, maybe. Seemed like it was something that was left over from the landscape, a part of the landscape. Or a part of it was part of a bridge project. It could have been debris that was left over from the bridge. It could have been a kind of an alien culture that made a pile of materials, and we don't now know what it's used for. Producing it involved making this dome, but also a very elaborate kind of ring beam steel structure on piles that are 10 meters deep. If you've ever lived in the Arctic environment of Edmonton, Alberta, you'll know what that means. The ground heaves up when it freezes. Panelizing the structure. And then working back and forth in collaboration with our engineers, Burrow-Happold, on optimizing the shape of the structure. Burrow-Happold wants the structure, of course, like their engineers. They want it to be a parabolic dome. And we're like, no, it's a pile. A pile is a very predictable shape. It's actually based on a concept, Auto explored this, called angle of repose. So you can predict the angle of a pile based upon the size of the aggregate. So we wanted this to correspond to approximately the size, the angle of the pile that these spheres would make. Panelizing it, studying that, studying how it would fit into the truck to go to Canada. We built it in Los Angeles, shipped it to from the 2,000 miles. I don't know what that is in kilometers. So we have to build again the formwork. Very elaborate. At about this time, we were invited by Andrea Zittel, who's a New York and California-based artist, to participate in her high desert test sites, which is this is the last project. I'm stopping. I tend to go over, but Andrea asked us to participate in high desert test sites. It's happening a few months before the Edmonton project's supposed to be finished, and we thought it'd be a terrible shame that we built and designed this elaborate formwork, this armature. Why don't we think of a way of adapting the design so that it could serve this dual purpose at high desert test sites? High desert test sites is about the kind of the intersection or the blurring the boundaries between what is art and what is life. It is in a remote part of the California desert. It's very hot. There you can see it on Google Maps. There's nobody living here. This is, I don't know, 50 kilometers, 50 kilometers, 30 kilometers, 30 kilometers. There's a salt mine right there. So we thought, well, let's take the formwork and let's adapt it and turn it into a swimming pool. which would be the most kind of, which was the most sort of disruptive or kind of unexpected thing that we could do in the desert environment. We didn't end up actually putting it on stilts like this, but we ended up sinking it into the ground. So the water becomes integral to the structural concept, the water counterbalancing the formwork in this hole in the ground. What this meant in terms of the design of the formwork is that the formwork had to go from being a disposable object, which would be torn apart with a sawzall and crowbar and thrown immediately into a dumpster as trash, to being something that could be dismantled and placed into a truck and then erected in the desert. So it meant unitizing the design. So this is broken into a series of panels. These are them fitting into the truck. That's the theory of how it fits into the truck. It doesn't really actually work that way. God. All right. So there it is coming. There it is going together. This is very big. Usually I think we have a good sense of scale. We didn't on this. When we got out there, we got out there, and I was traveling. Gaston calls me. He's like, "This thing is really big." I'm like, "Yeah, well, I mean, it had to be big because it had to have a presence in the landscape, something like an earthwork." But we couldn't really contemplate how large it was until we started putting it together. And you can see just skinning it with strips of furring strips is the cheapest way of making a surface so that we can start to weld the balls. Then another problem of making this is the scaffolding. We called this the Donkey Kong scaffolding. It was, I mean, if this was done in a regulated environment, the project would have been 3 times as expensive because of the safety issues. But fortunately, the people that I work with have a lot of, they're really stupid. So take it apart. There it is. Then take apart the formwork. Then we took the formwork out to the desert. I'm missing a couple slides here. But then the Joshua Tree is known for climbing. It's like one of the best places for climbing in America. So it's kind of funny that in order to staple all of this strips of luan to create another surface on the inside of the swimming pool, we had to rappel using climbing gear. Bear in mind that there's nothing around this thing. So how do you solve the problem of the swimming pool? Well, you have a guy, we're close to Hollywood, so we have a guy come out and he sprays it with urethane foam, which expands and fills all of the gaps, and then it can become swimming pool. It gives you an idea of how remote it is. Now, this project, I'm explaining it to you guys about as designers, but this is really, it was more about creating a kind of social situation. I don't really think about it as much about a kind of a fine piece of design. It's more about pulling it off. You have a project that's a $600,000 budget, which is the Talus Dome, and then you have a project that's a $10,000 budget. And we don't want to take money from one project and put it into the other. So, this is more about kind of creating a kind of situation, a kind of environment, a kind of playground that would happen over this one weekend during high desert test sites. That's how you get into it. You can climb a ladder as well. And then meanwhile, we go back and we put this back together in Edmonton, which was very laborious. We don't still yet have, the landscaping is not finished, so I'm showing you crude pictures of it. And there it is. kind of, meant to be a public artwork which is meant for the scale and the speed of the automobile. That's very important to realize. I don't think a lot of people in Edmonton understand that, because they wanted it to be something that pedestrian experience. Like, how do you have a meaningful experience with something in a car? I'm like, well, that's the culture that you have, is the culture of the car. So we're going to make art for the car. And I think they're beginning to understand it. I always like this slide because you have the kind of hot environment and then the cold Arctic environment, and I'm going to stop because I'm way over time. Thank you. Am I out of time for questions? We have.
You're in time.
Okay, so it went too long.
So any questions for me?
You have one. Do you have one?
I will
Invent one.
Hey, this is a really basic question actually, but I went to UCLA, so I'm really interested in the piece that you did there. Is that piece, so it can be dismantled, so they dismantle it and put it back together for performances, or it's always there, static?
No, it was never meant to be dismantled and put back together. It was meant to be dismantled and dispersed into the culture.
So it was more like an ephemeral piece?
It was decidedly ephemeral, yeah.
Okay.
Yeah.
Cool.
So, I mean, there's pieces of it all over the world now. Like, somebody called me, said that they saw one of those tables in London.
That's
So,
really cool.
I mean, the idea is maybe that it would become like, if we could find a venue where we could have a bigger budget, we would make them really, really precious objects, right? And then it becomes about a kind of making a myth about the tables. So when you possess one of these tables, you possess the story of where it came from as well. But it worked, at UCLA it worked very well, because the tables were obviously pretty low cost. They're pretty, they're like IKEA, basically, in terms of their, thickness and materials. So they worked very well for students. So it was a good culture to distribute it into.
In one of your slides, in one of your slides, you showed the string which is like free falling, and also had the print of the brick. So is there a sort of phenomena that you used in mapping that, or something like which is more anamorphic, maybe, I don't know.
Do you mean in the arrangement of the string?
Yeah, in the arrangements.
Well, there's several factors impacting the shape of the space that they create. One is the space itself. You have anchorage points. You have a limited options with regard to anchorage points. Another is how we want it to relate to the body. In the case of the piece at the museum that was very colorful with multiple colors, we based the arrangement of the strings on the relationship of the entryway to the shape of the space of the strings, so that it would force someone to walk around the piece, all the way around, to enter into this kind of cathedral-like space. And again, because I wasn't really talking so much tonight about the experiential aspects of it, I was talking more about the kind of the how did we get there, the how versus the why and the what. But yeah, there's a lot of factors. But essentially, the production method defines a certain set of formal possibilities. We can't. So once we define that, once we understand enough about the production method, then we can become designers, right? In the way that most schools teach design, which is like make shapes, right? Like when I was in school, you made shapes. I don't think you guys make shapes here, so I don't. But some schools, they still teach you to just make shapes. So in this case, we know the range of shapes that we can make, and then we can start to discuss what could those shapes mean relative to the human body, what do they mean relative to visual perception.
Thank you.
Yeah. Hi.
Hi.
Considering the factor that all your form works were not anything like standard ones, they were all more complicated forms and shapes. So how far were you able to manage the precision or the errors that were generated because of that?
How far were we able to manage the errors?
Yeah, errors or the precision.
It's a very good question. You know, that's a matter of experience, and it's something that we, depending upon who's putting it together, we will make an assessment about how sophisticated it should be. In this case, the guy's putting it together, James, he's our foreman. You know, he can make anything work. But he's also having a very direct discussion with the guy who's modeling it the whole time. In fact, he's telling him how he wants the joints to be made, so that one of the challenges in making an egg crate, I saw a bunch of egg crates out here, is when you're doing it at that big of scale, how do you get it? It's one thing to do it at that scale, because you can twist it and manipulate the material. You can bend a piece of microply like this much, right? But you can't do that with a piece of thick plywood. So I think in that case we built mock-ups, and we tested all of the connections. And when we learned something, we fed that back into the computer model, and we went through multiple iterations. Some of those iterations were just making models. So if you can put the model together without bending the material, then you know you're getting close to working in the way that you would work at full scale, where you can't bend the plywood, right? So, you know, but to answer your question about is it accurate, accuracy doesn't really mean that much in that case. I mean, it's tolerance, right? That's the word that we would use, would be tolerance. What's your tolerance? And our tolerance in something like that is pretty high, because there's no performance criteria other than it has to hold together, and it needs to make this shape, right? And whether it's you know 3 centimeters out of shape, it doesn't really matter as long as it's flat on the back wall. So if it was something that had to perform, if we were making a skateboard ramp, for example, we would be thinking about a lot different tolerances. They'd be much smaller.
Well, what you're saying is in study about the material.
Sorry?
What you're saying is in answering the study about the material.
The what? I'm sorry.
Material.
It's all about the material.
But what about the workmanship? Have you ever imagined constructing the same using people who haven't worked with you, where it is being fabricated?
I think that's an interesting question as well. I think that's always a consideration. I mean, if we were to work on a project where we were, say, working with untrained or unskilled labor, that sets up maybe a different set of challenges. We would probably devise a production technique that didn't require the kind of experience that, you know, the people with my studio have. An example of that would be the Catenary Projects. All you have to do to make the Catenary Project is know how to measure and know how to count. No, I mean, a lot of people don't do those two things very well. But you don't have to be a carpenter with with a lot of experience. So we knew in that Chicago project, in the MoCA project, that we wanted to do a project that would that would emphasize labor versus skilled craft, and so we kind of designed the whole method of doing it around the skills set of volunteers. And we made the system understandable by people who wouldn't be thinking about it critically, who could just show up for 2 hours and just cut string or hang string, and as long as they were hitting the 2 points that they needed to hit, then it was okay. So I think that's a very, very interesting question, because it starts to it suggests a discussion about how you as a designer can work in different cultures. If we were to go and do a project in Oaxaca, we would maybe some of the biggest resource that we could be working with would be people that make bricks. And how do we devise something involving brick making, and maybe just change that brick making technique just enough so that they're learning just a little bit from us and we're learning a little bit from them. So it's always that exchange. It's always finding that overlap and that middle ground. That's a really interesting thing for us.
Thank you.
I have a question as well.
Okay.
First of all, I would like to thank you for the very inspiring presentation. It's great because you have bombarded us with a lot of projects, and that's always inspiring. And while seeing the project, I was thinking, it's quite obvious that the basis of your design is on the component or on the particle or on the unit, or call it as you want to call it now, but it's this kind of understanding the whole out of the parts, and then by different variations or configuration you are creating your final design. And this is like a very dynamic design, which is obvious in the project of the string, the spheres, the section project of the landscape with the shifting section, and it's very beautiful. And then I was thinking the connection with the second, with the start of your presentation, the second slide that you were showing, the car of different parts, no? So this kind of hybrid of recycled parts. And I was wondering whether you have been working, or you are interested in, or you are planning to work on thinking of this kind of unit and component design on recycled materials, or on different kind of patches, that it could probably create a big collage of
It's funny you should ask. That's a very good question, and if I'm going to just quickly show something, because this requires me to show a slide.
Am I already knowing your next project?
I want to show one slide of a project, but it's funny you mentioned this, because I'm kind of we reached a dead end with, we just get sick of working with aggregations. I get for me. When I start to hear it, like that term used everywhere, it's time for me to move on. So like I hear it, we heard it quite a bit over the last few years, and so we started trying to think about ways in which we could maybe do something different. So I'm just going to show a quick image of this slide, this project, which I didn't get to, but because it involves all of what you just said. We had been working with, come on, okay. We've been working with paper pulp working with pulverizing paper, recycled paper, and blowing it through a stucco gun to create shell structures. And we did it on a couple of projects where we're spraying it over balloons. So you spray paper, recycled paper, you grind it up with a big blender, and you put it into a pressurized gun, and you shoot it as pulp and water onto formwork. And then if the formwork is pneumatic, then you remove the formwork and you have a shell. So we were very interested in that. We did some stuff with our students in that. And then we did a project, a couple of projects with it, and then we had this opportunity to work at SciArc and to do an installation there. And we wanted to do something that was definitely kind of different than this kind of aggregating approach that we'd used before. So we decided what we would try to do would be to mold big physical objects out of paper and to make surfaces out of them. Rather than casting paper, if you cast the paper in this bottle, you come out with the shape of the bottle, the volume of the bottle. What we were more interested in was actually creating the negative impression of the bottle, so spraying it and creating a shell and then removing the shell. So you have the negative of the bottle. Coincidentally, at the same time, a friend of ours, this is the project that we did, which was involved making 3 Volkswagen Beetles out of sprayed paper and 2 speedboats to make a kind of iconic architecture, kind of direct quotation architecture, the kind of the duck of Venturi in the 21st century. But it wouldn't have been interesting to us if we hadn't used this technology, which is 3D Lidar scanning. And coincidentally, I have 2 friends who are who just finished at the Bartlett, who have access to a Lidar scanner. And so we asked them to come to LA and scan all these objects. And then, so the idea is that you scan the object, you create a formwork within the object, which becomes the panelization division lines, and then you reassemble the object, and it becomes a self-supporting structure. But our dream for this was to do a swimming pool. Los Angeles has a lot of these, right? I don't think you see these in Barcelona. The kidney bean swimming pool. It's a very iconic California form. But it's also a dome. And it's also actually form found because the shape and the curvature of it is based upon hydrostatic phenomenon, and the engineers worked out. So we decided to scan a swimming pool, and that we would attempt to spray a swimming pool, make a paper shell of that, and then remove the shell and then turn it upside down and turn it into a dome in the SciArc gallery. And it would be supported by this guy, which is like this man, which is like, these things were made in the roadside people. They were originally carrying mufflers in America throughout the second half of the 20th century, so they're everywhere.
We really need to come to LA. I mean, that's it. You convinced us already.
All right, so anyway, recycling and molding, yes. We did a VW bug. All right.
Okay, I think we can leave it here. Thank you very much, Ben, for being here with us. And we can continue actually speaking in a more informal way with a drink. Thank you very much.
Thank you.